We'll be discussing how to solve matrices using Gauss-Jordan elimination. And instead of doing regular row echelon form like in Gaussian elimination, we'll be learning how to do reduced row echelon form. Gauss-Jordan elimination essentially produces a matrix in reduced row echelon form, where there's ones across the main diagonal and zeros everywhere else. This is so we don't have to do back substitution like we do in regular Gaussian elimination. So I'm just going to be copy-pasting the steps that we did from the previous video of Gaussian elimination. And now we're going to be converting our row echelon form into reduced row echelon form. So to do so, let's create a goal for doing our next set of row operations. So we can see from our previous row operations of our matrix that we have the last row isolated already, meaning that we have already found the value of z. Now we have to do the same for x and y. So let's say our goal is to isolate y in the second equation and use the third equation to eliminate z from the first equation. So in order to eliminate z from the first equation, all we have to do is multiply 3 by equation 3 and add that to equation 2. Now this works because when multiplying equation 3 by 3, now we have 0, 0, 3, colon, negative 6, right, from the previous matrix with the row operations. And by adding that to equation 2, essentially what we're doing is we're eliminating the z value from equation 2, so now it's just 0, 1, 0, colon, negative 10. Now the same kind of concept applies when trying to isolate y in the second equation. All we do is multiply negative 4 by 3, and we simply add that to 1. This is because when you multiply negative 4 by 1, which is the value of z in the last, or the third equation, negative 4 plus 4 equals 0, and instead of 1, 3, 4, colon, 7 in the previous matrix, we now have 1, 3, 0, colon, 15. And now all we have to do, since we already have the second and third equation ready, is we just have to isolate x in the first equation. And we can do that by doing negative 3 times equation 2 plus equation 1. By doing so, we're just eliminating the y value from equation 1 and therefore isolating x. Now, can we check, is this in reduced row echelon form? Basically, again, what that means is that is there 1 across the main diagonals and 0 everywhere else, except for, of course, the constants, which is 45, negative 10, and negative 2? Yes, it is. So therefore, the answer is 45, negative 10, negative 2. And a short tip is please remember to use each row operation to try to eliminate variables so you can have 0 as a coefficient where you need it. I hope this video helped. Comment down below any other math topics from my review. Thank you.